Hello guys, welcome to this lesson. So in this lesson, we'll be looking at scalar projection. Scalar projection. Okay. And we have a line. So if you have a vector, let's say we have a vector like this on a straight line. Let me clean this place. So if we have this kind of vector, let's say we have another perpendicular line here, it's perpendicular to this point. Um, so we can have so let's say this is angle theta, and if this is vector b, so if this is vector a and this is vector c, it goes in this direction. So scalar projection of a vector can be thought of as like the shadow of a wire. So you know when you are walking in the sun and then you have your shadow. Sometimes your shadow will be by the side, be by the front or at the back, depending on the time of the day that you are inside the sun. So those shadow can be seen as projection. So projection is just like a shadow. Okay? Projection equals to shadow. You understand? Just in vector form, we give it the name projection. So the original vector is the person. So the original vector is you that you are walking, but your shadow that is not real is called the projection. Okay. So uh, original object or person equals to vector. So what we, of course, we know how to find vector now. What we don't know how to calculate is the shadow, the length of the shadow using a vector form. So how can we use or calculate length of shadow? That is the topic, scalar projection. That is what it's all about. So scalar projection is a way of finding uh, the length of a shadow casted by an object. So in this diagram, is vector C is the vector projection of vector A in the direction of B. Okay, so the magnitude, so here C equals to uh, vector projection vector projection of A in the direction of B. Okay, of A in the direction of B, in the direction of B. Okay, so if we take the magnitude of C is called the scalar projection. Okay, scalar projection is a scalar, not a vector. So if we take the magnitude of C is called the scalar projection. And how can we compute that? We can basically compute that using the knowledge of Pythagoras theorem and you know, the distance between 2 points. Okay, so let's see how we can compute those values. So let's draw the diagram again, or make it clear now. So we have this line, we have this place, and then this diagram. So this is C, and this is hypotenuse is A. So if we project it further, let's project it backward a little bit. So we have B here. Okay, so let's put the direction. This is the direction, and this is how it goes. Alright, so we have B. Now look at this angle theta that is between this place is this. So you know that by computation cos theta is equal to C all over A, right? Adjacent over hypotenuse. Yep, yep. So magnitude, please. Magnitude of C all over magnitude of A. We also know that from angle between 2 points, cos theta equals to A dot B all over magnitude of A, magnitude of B, right? Is it making sense? Yep. So if we equate the equation stars, then we're going to have that magnitude of C over magnitude of A equals to A dot B all over magnitude of A multiplied by magnitude of B. So that magnitude of A and magnitude of A will cancel each other here, and then we have that magnitude of C equals to what? So therefore magnitude of C equal to A dot B all over magnitude of B. And this is called the vector projection. Vector projection of A in the direction of B. So this is called the C, where C, sorry, pen. So where C equals to vector projection, so scalar projection of vector because of the magnitude. So C is equals to scalar projection of A onto B. Let's say onto B. So that's the computation. So that's the value. This out of, so all you need to know is this formula. Okay. So let's look for examples. Example 1. Consider the vector. Example 1, we have the vectors. Consider the vectors. A equals to 5i minus j. B equals to 3i plus 4j. Okay. Let's say A. Find a scalar projection of A onto B, and the B, find scalar projection of B onto A. So those are two different things, and then we must be careful when you're calculating this. This question normally comes out in white if you're writing white. Alright now. So let's start with A. So projection A onto B equal to magnitude. So you don't need to draw it, but if you want to, you can draw it, okay? So you can just state your formula right away. So that would be A dot B all over magnitude of B, so which is 5 times 3 plus minus 1 times 4 all over magnitude of B, which is 3 squared plus 4 squared. Okay? And that is 15 minus 4 all over magnitude of 9 plus 16, so which is 11 all over square root of 25, which is equal to 11 over 5, which is equals to 2.2. So scalar projection of A onto B is 2.2. So therefore, scalar projection of A onto B equals to 2.2. Okay. B onto A. So that one would be B dot A all over magnitude of A. Okay. All over magnitude of A. You can see how it changes. So that would be 3 multiplied by 5 plus 4 multiplied by minus 1 all over magnitude of A, that is 5 squared, plus square root of the square of 5 squared plus minus 1 squared, okay, and that is equal to 15 minus 4 all over square root of 25 minus 1. Okay. So that would be equals to 11 all over square root of 24, which is 11 all over, what is the square root of here? So this is 2 root 6, 11 over 2 root 6. So therefore, scalar projection okay, oh sorry about that. This is square, so we are not supposed to subtract. So this place is 25 plus minus 1 squared. So that will be equal to 15 minus 4 all over square root of 26. Okay, so which is 11 all over square root of 26. Okay, so we cannot leave it like this. We need to rationalize. So 11 times root 26 multiplied by root 26 all over root 26. So that would be 11 root 26 all over 26. So this is how you work out scalar projections. So you can see the answer is not the same. Projection of A onto B, we had 11 over 5. Projection of B onto A, you can see what we got. So I'm going to leave you with some classwork, okay? So you test your knowledge and find out this. So classwork. So given that A equals to 4I minus J, B equals to 3I plus 4J, find scalar projection. Scalar projection of A onto B, B onto A. Okay, so this is your classwork. So, and in the last lesson, we'll be looking at vector projection. See you.